Hello and welcome to another IB Mathematics video. We are going to be talking about probability, and probability is something that people talk about all the time. It's nothing about it. People say, if I don't leave now, I have a big chance of missing the bus. Or you finish an exam and you say, I have a good chance of passing, or I don't have many chances of passing, or many other things. So probability is something you hear all the time. So we're not going to be talking about something mystique or abstract. We're going to be talking about something very common. So the most typical way in which mathematics teachers have been getting students excited about probability is that probability will help you win at games. And if you've heard legends about people who go to casinos and make a lot of money, it's because they understand the laws of probability. Let me tell you, casinos also understand the laws of probability, and they've got those figured out pretty well. So don't fall in that trap. Now, how to win at games? Well, probability is going to help you win at games because you're going to know what the chances are. Very visual, very evident example. You flip a coin. There's actually three possibilities. You get heads, you get tails, and you get edge. Then it falls on the edge. Which one would you bet on? Would you bet on edge? You wouldn't. Why? Because the chances that happens are extremely small. Most likely you'll get heads or you'll get tails. You vote for one of those two, right? But this can get a little more complicated. Let's think that we're rolling two die of 6 faces. So you can get a 1, 2, 3, 4, 5, 6 in one die, and 1, 2, 3, 4, 5, 6 in the other one. Now, what's going to be what's more likely to happen? Say, for example, Matt, Lise, and Kate are betting for numbers, and Matt says, I'm going to get 2, 3, 10, and 11. Lisa says 6, 7, 8, 12. Kate says 1, 4, 5, 9. So who do you think will win? Well, there's actually going to be more chances that Lisa wins. And you can see it here because there's more combinations where there's a 6, 7, 8, or a 12. 12 not so many, just one combination, but all these combinations here add up to 7. So if all the possible results that can come up, which supposedly will all have equal chance, and these ones here add up to 7. 7 of them add up to 7. 5 of them add up to 6. 5 of them add up to 8. 1 of them adds up to 12. So it's obviously better to go for 7 than it is to go for 12. Now, do keep this in mind, because this is something that often students get confused about. This is just probability. It says that you have a better chance. It does not mean that we're guaranteed that Matt will lose. You never know. It's probability. Anything can happen. But it's just that technically Lisa has a better chance of winning. So, let's look at these numbers. Let's look at this combination. Look at these percentages that we got here. Okay, first thing, is it a coincidence that this happens? That you add it up and it comes up to 100? No, it's not, because we have considered all cases. We considered 100% of the cases, so it's not a coincidence that this happens. And finally, we're going to take a quick look on how do you calculate these percentages in a more technical way, because previously we were counting how many squares were in the right color. In this one, what we're going to be doing is we're going to be coming up with a formula, and this is the formula, and this formula is in your formula booklet, so you don't have to memorize this. It's going to be available in the exam for you, and the only thing that you do is you count in how many combinations does Matt win, or does this event happen. This case A take happen if we're dealing with probability of A, like we have in the formula, and you divide by the number of different combinations in total that you have, whether he gets them or whether he doesn't get them, all of them together, and that's how you get the percentage. But before you get a percentage, you're actually going to get a decimal. So just keep in mind that this is the same thing, because this little number here just means divided by 100. So in mathematics, the way we express probability is normally with a decimal number between 0 and 1. And 1 is going to mean that it always happens, and 0 is going to mean that it never happens. So you can see like there's other values here. We can easily change that into a percentage. 0.03 is going to be 3%, 0.99 is going to be 99%, etc., etc. So it's not something very mind-blowing, the way in which You normally would talk about probability in mathematics because we're used to hearing about percentages in real life, so it's not something very far-fetched. And now here comes let's start to develop this. We've explained what probability is. It seems logical so far, and it makes sense what we're dealing with. Let's start to think about it, because this is what we do in mathematics. We come up with something straightforward, and then we start to think about it and move it around and come up with new ideas. This is the first one. It's a fairly easy one. This is the complement. So what does a complement mean? Is that suppose that you have the possibility that an event happens. Well, the complement will be the possibility that it doesn't happen. Simple as that. What is the probability of me getting a 5 on a die? Well, I could also ask what is the probability of not getting a 5? And when we write the complement like this, the probability of not A, this is the probability of A, probability of not A, and of course they're going to add up to 1. Okay, so that's the complement, and this little rule is going to be useful, because sometimes it's going to be easier to calculate the complement than to calculate what the actual question is asking. Here's an exercise, you can look at it. It actually comes from real statistical data. So I think it's interesting to look at it. It talks about the possibility of finding a job after leaving education. We're going to use the complement to calculate it and the total number of cases. So the two formulas that we've seen earlier on, I recommend that you try this exercise and give it a look. It's very interesting. Furthermore, similarly as we saw in sets, when we talk about probability, we are going to be finding that the probability of two events occurring sometimes overlap, sometimes they get together. Because let's think of this very clear example. The probability that it rains and the probability that it's windy. Now, of course, when it's raining you have bad weather in general, and it's more likely that it's going to be windy. On your typical non-windy day, you might get like the sun falling on top of you, and it's going to be a calm, non-windy day. It depends on the region of the world you're in, of course, but imagine that you have this relationship. You might say that there is an overlap of the probability that it rains and the probability that it's windy, or that there is you could unite them and say like, hey, what's the probability that it's raining or it's windy, and it will give you different values. Brings us to one of the most important concepts to understand, a very hard concept, and students struggle with this one, but it's incredibly important. It's not that common that you will find it in an exam exercise expressed in a straightforward way, to ask you about dependent and independent events. But the truth is that you are going to need to understand, because this is part of the core of what's actually happening when we're dealing with probability. So what's an independent and an independent event? Well, sometimes events are related. Is there a relationship between the probability that it's cloudy and the probability that it rains? Well, yes, because when it's cloudy, it's likely that it's going to rain. However, is there a relationship between the fact that the day of the week and the chance that it will rain? Not really. I mean, I don't think the weather knows what day of the week it is, right? And so one would say it's dependent because the probability of one thing affects the probability of the other, or vice versa. And it's independent when it does not affect. So it's important to remember the idea of dependent events and independent events. And that's all we're going to be looking at for now in probability. Just remember the simplicity of how you actually calculate the probability of something, which is count all the cases when it happens and divide by all the possible cases. Remember the idea of the complement, which is something probability of something happening or the probability of something not happening, and you add them together and it's going to give you 1 or 100% if you prefer talking about percentages. And finally, the most importantly, the idea of dependent and independent events. So that's all. Thank you very much for watching.